Alright, in this video we're going to give you some hints for the Magic Square Lab. So let's just refresh our memory of a few things about the Magic Square. First off, we're guaranteed that it's going to have an odd dimension, and I'm going to use dim for dimension. In this first one I have picture, dim would be 3, and in the second our dimension would be 5. And we're going to just label our rows and columns. So right here I've got rows 0, 1, 2. Those are our rows. Down here, 0, 1, 2, 3, 4. And the rows are here, whereas our columns are up here, 0, 1, 2, columns, and here 0, 1, 2, 3, 4 are our columns. Okay. And then we're going to have another value called count. Now dimension's not going to change, but count is going to. And count is the number that we place in there. Or you could call it whatever you want, but I'm going to call it count. So count starts at 1. And the very first thing we have to do is place that 1 in correctly. And we're going to be keeping track of what row and column we're in. So let's keep track of our row and column. So these are kind of the values that you're going to need. You're going to need to know what number are we placing in there, what's the dimension, and what row and column are we placing it in. So the number 1 always goes in the top row center. So row starts at 0. That is the initial value of row every single time. Column is this middle one, and so let's just take a look. If my dimension is 3, column starts at 1. If my dimension is 5, column starts at 2. So let's just start looking at this pattern. 3, 1, 5, 2. Let's just imagine if we had a 7 by 7, right? We'd be 0, 1, 2, 3, 4, 5, 6, and we'd see the middle one is 3. So if my dimension is 7, then column is going to start at 3. Now you might think, oh wait, I subtract 1 and take half. You don't have to work so hard because this is one of those times when int division is your friend. So notice how I can do 3 divided by 2 and that equals 1. And 5 divided by 2 equals 2. And 7 divided by 2 equals 3. So you'll notice that the very first value for column is your dimension divided by 2. All right, so let's get some of this put away. So our column is going to start at dimension divided by 2. All right. So now the next thing we need to do is we're going to be looping through until we're through all the numbers, and we know what numbers we're going to go through. So count starts at 1 and it's going to end at, well, in this one it's going to end at 9, and in this one at 25. And so hopefully you're like, oh yeah, it's going to end at dim squared, or easier, just dim times dim, right? So for instance, that would be 9 or 25 is where we end. So we're going to have a for loop that starts at 1 and goes all the way through dim. And then to place something in the square, and I don't know what you're going to call your array, but you could call it something like square, you would say square row column equals count. And you've now just placed the number 1 into row 0, column dim 2. Now after we've initially done that, we have to adjust row and column to find the next place we're going to place it. Now to adjust row and column, there are 2 rules. And I'm going to take the exception first, which is if we're divisible by dim. So we're going to start with this one. So if we're divisible by dim, so remember in this first one, if you're divisible by 3, or in this one, if you're divisible by 5, we just drop down 1. And so you'll recall, let's see, 2 goes here, and 3 goes here. So here's the first case where it happened, and we just dropped 1. And when we drop 1, what happens is our row changes. And you notice here our row goes from 1 to 2. So row is going to go plus plus because it got bigger, and the column, nothing changes. The column stays put, so I don't have to do anything else. But otherwise, what am I going to do? In all of the other cases, I'm moving up like this. And So let's say I have 4. Let's take the normal case where it doesn't go off the board. I'm moving up like that. Or if I'm here, I've got 2, I'm moving up like that. So what happens in all those other cases? Well, let's see. Our rows, in this case, goes from 4 to 3. Or from here, our row goes 2 to 1, which means my row actually decreases. Let's look at our column. Here, my column goes from column 0 to 1, or here, column 3 to 4. So we see that our column actually increases. Now, after we've done that, and that works here as well, so let's take this very first case. After we've done that, we're going to check to see, did we go off the grid? So now check if off the grid. Check if off the grid. Now, there are 2 ways we could be off the grid. One is if we're above. So that happens here, it happens here. Well, if we go off the grid, what is my row? And we can see, oh, my row would be -1. So that's our first one. If the row is -1, well, what do we do? If the row is -1, I'm going to erase some of this here. So I'll start over here. So I have 1 right here. I go up here. I'm trying to place 2. I'm off the grid. I drop right down to the bottom. Now notice I did not change my column. I only changed my row. And what happened to my row? Well, it went down to row 2. Now what happened on this one? It went down to row 4. The bottom row, how is that related to dim? Oh, it's 1 less than dim. So now I can say that row equals dim minus 1. All right. So then let's take this. We place our 3 here, and we're going up and over, and now we've gone off the right side of the grid. Well, how do we know we've gone off the right side of the grid? Well, if I go off the right side of the grid, what happened to my column? My column is, oh, it equals dimensions. See how out here it's 5? And I'm off the grid. That's the same as dim. Same thing here. My column would be 3. So I could say if the column equals 5, I suppose that need to be a double equals there, then I go all the way over here. Okay? And, oh, I just switch column to 0. And there we go. We've basically worked out how to change those, and I have to basically do this over and over again in a for loop all the way from 1 to dim times dim. Now, the next part of the problem is to check the sums. And each checking sums, and you have to check rows, columns, and diagonals, they each involve nested for loops. So for instance, when I'm checking the rows, I start at row 0. And you should note that in row 0, I need what's in 0, 0, 0, 1, 0, 2, and I'm just putting kind of the coordinates of these, 0, 3, and 0, 4. And I'm going to add all of those. Now you should notice that as I went through this, the first one equaled the row, okay? So your outer for loop is going to be the row, and the inner for loop is going to change your column values. So your inner for loop is going to go through 0, 1, 2, 3, 4, and it's going to figure out the sum, and it's going to print it. And then it's going to do the same thing for row 1, but this time it's going to be 1, 0, 1, 1, 1, 2, and so on. Let's see, I'll get the rest of these in. 1, 3, and 1, 4. And you'll notice once again, we've got the same thing going on where the first number matches the row number and the others go 0 through 4. And you know where to end because it's less than dim. All right? So you do that for each row, and it's going to print out the sum for each row. And so when you're checking rows, so for rows, the outer for loop is rows. So outer loop equals rows, inner loop equals columns. Now, for column sums, you switch them up. Now your outer loop is going to be your columns, and your inner loop will be the rows. So if we take, for instance, right over here, column 4, you're going to see that the columns all stay with 4. And you'll notice that the column values, oops, here we go, were all 4. They match up with this. The rows go 0, 1, 2, 3, 4. Now the hardest one is when you go to do the diagonals, and there are 2 diagonals. One of the diagonals is super easy and the other is trickier. So let's see, I'm going to do this on a fresh page. So we'll go in here and let's just clear this out. So for the diagonals, we've got our 2 diagonals. So for our diagonals, the first diagonal is obvious. It's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. And you don't actually even need a nested loop because those numbers are all the same and you add those all up. Now for the other diagonal, this is the tricky one. Over here, I'm at 0, 4. Oops, I wasn't using parentheses. Let's try that again. So 0, 4, and then this is 1, 3, 2, 2, and then let's see, what are we at here? 1, 3, I have to think so hard. 0, no, this is 4, 0. Let's try that again. Oh, 4, 0, right? Yes. Row 4, and I did this one backwards. See, it's just hard writing it out. All right, so this is row 3, column 1. Okay, so I've got them now. So in the first one, I'm basically doing sum plus equals, let's say you called this square RC. They're the same. In the second one, so that's for that one, and in the second one, which would be this one, I'm going to be doing sum plus equals square, and let's say you're starting with R. This value is not the same, so how do I get this value? And I can use, so it goes 4, 3, 2, 1, 0, and so I can take the dimension minus 1 minus R, right? So let's check that out. So our dim is 5, right? 5 minus 1 is 4, and 4 minus R here is 0. And here, 4 minus 3 is 1, 4 minus 2 is 2, and so forth. So there's that formula for what I'm going to add. And of course, both of these have to be in a loop. So I need a for loop here, and I need another for loop there. All right, I hope this is helpful in completing this lab.